Okay, so this is the question that you posted. So let's get down to the first one, part A. What's the probability of picking a king? So the probability of picking a king is going to be a fraction, and in the denominator we're going to have the number of cards in the deck. And in the numerator we're going to have the number of kings in the deck. And so there are 52 cards in our deck, and there are 4 kings in the deck. Now, that's a correct answer. As a fraction, it reduces to 1 over 13, but it says to give the answer to 3 decimal places. So if you do 1/13 in your calculator and take it to 3 decimal places, you're going to get 0.077. Okay. All right, part B. What's the probability of picking a king given that the card is a face card? Okay. Well, given that it's a face card, what we need in the denominator is the number of face cards in the deck. And what we need in the numerator is the number of kings that are face cards. So there are 12 face cards in the deck, 4 kings, 4 queens, and 4 jacks. And all of the kings are face cards, so all 4 kings are face cards. And so that one will reduce to 1/3. And if you take that to 3 decimal places, that's going to be 0.333. Okay, now part C. What is the probability of picking a face card given that the card is a king? Okay. Well, think about it logically. If I pick a card out of the deck and I tell you it's a king, well, if it's a king, it's already a face card. It's automatically a face card. So it's absolutely certain it will be a face card, and the probability is 1 when something's absolutely certain. But if we're going to go through the motions of this, the probability that you pick a face card given that it's a king, that's going to be a fraction with the number of kings in the denominator, and then in the numerator, the number of face cards that are king. So there's 4 kings. And then how many face cards are there that are kings? There's 4 face cards that are kings, the 4 kings themselves. So it's an absolute certainty. Now, if they're going to be fussy and want you to take it to 3 decimal places, then you can write that. But the answer to that is going to be 1. Okay, now part D. Are the events king and face card independent? Okay, so if king and face card are independent, then you have to have the probability that you get a king, given that the card is a face card, is the same as the probability that you pick a king. That must be true. But we saw in part B that the probability of king given a face card is 1/3. Or 0.333, and we saw in part A that the probability that you get a king is 1 out of 13, and these numbers are not the same, and so the answer is no. King and picking a face card are not independent. Okay, so right, so it would be that one. That would be your reason. Okay. All right, and now let's finish out the rest of them. Let's see, where's part E? Okay, what is the probability of picking a spade? Okay, so now I'm going to clear this. Part E, what's the probability of picking a spade? Well, it's going to be a fraction, and in the denominator, you want the number of cards in the deck. And in the numerator, how many of those cards are spades? There are 13 spades in the deck. Okay, and so that will reduce to 1/4, which is exactly 0.25. That's the exact answer. Now, if this rounding to 3 places, if they're really, really picky about it, then they would write it like that. They just want that 0 there, and that takes it to 3 places. But depends how picky your teacher is. Okay, F. What is the probability of picking a spade given that the car is a 2? Probability of picking a spade given that the card is a 2. Okay. Well, how many 2s are in the deck? The total number of 2s. There are 4 2s in the deck. 2 of diamonds, 2 of hearts, 2 of clubs, 2 of spades. Okay. And then how many? So the number of spades that are 2. Well, there's only one spade that's a 2, the 2 of spade. And so the answer to that one is 1/4. And that's exactly 0.25. And again, if you take it to 3 places, it'd be 0.250. Okay, G, what is the probability of picking a 2? So getting a 2, given that you've been told, or that you know that the card that you've chosen is a spade. Okay, well, how many spades are in the deck? There are 13 spades in the deck. And then how many 2s are in the deck that are spades? Well, there's only one 2 that is a spade, the 2 of spades. Okay, and so that will be 1/13. And if you take that to 3 places, that's 0.077. Okay, and now part H, our spade and getting a 2 independent. Well, if they're independent, we have to look at this. What's the probability of getting a spade given that the card is a 2? And what's the probability of getting a spade? Okay. Now, if these are equal, then the answer is yes. If they're not equal, the answer is no. Okay, so this one, the probability of getting a spade given that the card is a 2, we found out in F, and that was 1/4, which was 0.25. And then the probability of getting a spade from the deck, we found in part E, and that was 0.25. These are the same, and so the answer here is yes, because those are the same. Okay, so I think that's everything that you asked for, and thank you for letting me help you.